This is video 2 of the Psych 642 MANOVA assignment. So picking up right where I left off when the recorder cut the video off, I just finished factoring the predictor variable of degree and making sure that all of its labels were correct by looking at the data here. So now I can take a look at some of the descriptive statistics. I'm going to do this by using the by function in conjunction with the stat.desc function to get like the mean, median, mode, standard deviation, standard error, things like that of the two outcome variables based on the groups of degree. So gonna run that, and looking at this we can see the information for perceived competence in working with bisexual clients and actual competence. It looks as though the mean for counseling psychologists is the highest for both the perceived competence and actual competence, with clinical psychologists being the lowest in both, and the Masters in Mental Health Counseling being in between the two. So now that we've taken a look at that, I'm going to test the assumptions. So the first assumption that I'm going to test is the homogeneity of covariance matrices. I'm going to test this. There is no specific test that can be used in R, but I'm going to use the by function in conjunction with the COV function to look at the different covariance scores and variance scores. I'm going to tell it to print or calculate these different matrices. So once again, using in combination the by function and the COV function, I'm going to specify that the grouping is done by, once again, the predictor variable degree, and looking at competence data specifically, the data will be in columns 2 to 3. So let's run that and take a look at these. Alright, so you can see down here the variance in perceived competence in bisexual clients. There's quite a big jump for the mental health counselors, so there's not really homogeneity of the variance here. And then looking at the covariance scores, you can see that they're not too incredibly different, but there is some variance there as well, just not nearly as much. Not nearly as much as in the variance of the perceived. Now for the actual competence, the variance there is fairly similar. I think if I remember correctly, the threshold is if it differs, I think it's either by 2 or 2-fold. And in this specific case, neither of those I don't think would be the case, but the assumption is still not met simply because of how much larger this is compared to the other variances. So now that that assumption has been tested, I'm also going to test the assumption of multivariate normality. Before this can be done, though, each of the different levels of the groups, so the counseling psychologist degree, clinical psychologist degree, and mental health counseling degree, have to be separated out. So I'm going to do that by specifying that I'm taking rows 1 through 10 of column 2 and 3 from competence data to be counseling psychology, and then rows 11 through 20, 21 through 30, all of column 2 and 3, specifying each one specifically. I'm going to use the T function to transpose the data because initially it's in columns, which we can see we're specifying columns 2 and 3, and the data needs to be in rows rather than columns in order for the multivariate normality Shapiro test to work. So I'm going to use the T function to transpose it from columns into rows. So I'm going to do all of that now. And then now that the data is in the correct format, I can run the multivariate Shapiro test using the M Shapiro test function on each one. And we can see that 2 of them do meet the normality test, but 1 of them is significant, which means that it does differ significantly from the normal distribution. So not only do we not meet the assumption for homogeneity of covariance matrices, we also don't meet all the assumptions for normality. So it may be appropriate to transform the data or to choose a more robust test, but for the purposes of this assignment, I'm not going to do that. What I will do whenever I get to running the actual MANOVA model is I will choose Pillai's trace statistic, which is one of the most robust test statistics for the MANOVA, especially whenever the assumption of homogeneity covariance is not met. So, but I'll get to that in just a minute. So next I'm going to set up the individual contrasts. So after doing the MANOVA, I plan to run individual ANOVAs to kind of parse out more of what's going on, since the MANOVA just gives like a general overall understanding rather than understanding of specific differences between the levels. So in addition to running the ANOVAs, I'm also going to set up contrasts to run after those specific ANOVAs. So I've set up, or I'm going to set up, each contrast as its own specific variable. One is going to be counseling degrees versus clinical degrees, and then the counseling degrees will be separated into master's versus doctorate in the second contrast. So I'm going to set those. And then using the contrast and C-bind functions, I will be setting the 2 new variables that I've created as the contrast for the degree variable in the competence data dataset. Okay, so now the contrasts have been set up. So now I can actually run the MANOVA model. So before I can do this, I have to combine the 2 different outcomes into one specific outcome variable so that I can put it in the model. So I'm going to use the cbind function to do that. So you can see I've used the cbind function and I'm combining perceived competence in working with bisexual clients and actual competence in working with bisexual clients together to be the variable outcome 1. Then I'm going to use the MANOVA function to create the model. You can see I'm using the outcome 1 variable that I just created as the outcome variable, and then using degree as the predictor variable. Okay. So now I'm going to use the summary function to get the results of the model, which we can see here that it was significant. So it does appear that degree has an effect on these outcomes of actual and perceived competence. So now I'm going to use the summary.aov function to get the information for the two ANOVAs. From looking at these two ANOVAs, remember that the first one is going to be perceived competence in working with bisexual clients was significant, but actual competence in working with bisexual clients was not. So it appeared that the degree had the effect here is from the degree's effects on the perceived competence and not the actual competence. So now I want to break specifically, I'm going to do them both, but specifically I'm going to be looking, since this one is significant, I'm going to be looking at the contrasts for the perceived competence, but I am going to go ahead and run both. And you can see that I'm creating the model, the separate linear model for each of the outcome variables so that I can look at the contrasts using the lm function, and then using summary.lm I'll be looking at the specifics of the contrasts. Okay, so this is the contrast that I'm going to be looking at due to what came up significant further up, and it basically shows that there is a significant difference in perceived counseling competence with bisexuals between people with counseling degrees and people with clinical degrees, but there doesn't seem to be any difference between the master's counseling degrees and the doctorate counseling degrees. Alright, so finally I'm going to do the discriminant function analysis using the LDA function. So specified the degree as the outcome here, and then the perceived counseling competence with bisexual clients and actual counseling competence as the predictor there. So I'm going to create that model, and then from here we can see the results of this. From these results we can see that we found two different variants, one that accounted for 96% of the variance and another that accounted for 4% of the variance. First variant produced similar coefficients for perceived competence and actual competence, whereas the second variant seems to have differentiated perceived competence from actual competence. Finally, I'm going to use the plot function to make a little bit more sense of